So this video is for the section 5.5 notes about rational expressions. And first of all, we need to define a rational expression. So this is simply a fraction that has variables. So in the old days, when we would have fractions like just 24/9, like the example I have down below, that's not really a rational expression. It's just a fraction. But I want to use this as an example to talk about what it means to simplify. So we've learned how to simplify a fraction, and there's different ways you might say that you're doing it, and you probably don't write out the steps. But when you were originally taught how to simplify, we said to break it down into factors. So like, for example, you might say that 24 is 8 times 3. Now, I know that's not the only option. You could break it down differently, but let's just say you choose 8 times 3, and you could break down 9 to be 3 times 3. And so that's why it's okay to cancel the 3's, because we're canceling the factors, and that means the only thing that's left is the 8/3. So really, that's what we're doing, even though we've gotten to the point where we don't really write it all out. So look down at my examples. So which of the following illustrates this principle? Well, what I'm saying is, in the first one, do you see that the 3 is being multiplied by the x plus 1? The 3 is being multiplied by the y minus 2, so that's why it's okay to cancel those 3's. However, in the second example, that 3 is being added to the x, and the 3 is being added to the y, so they're not factors, because factors are being multiplied. So it's not okay to factor those 3. That's bad. In other words, you can't do anything to this except leave it. Whereas on this one, when you cancel the 3's, all you have left is the x plus 1 over y minus 2. Okay, look at the third example. Do you see that there's this hidden multiplication between the parentheses? So those parentheses are both factors. So that's why it's okay to cancel the factor of x plus 1 with the factor of x plus 1 and just leave you with what is left. Whereas, and this is probably the one that's the hardest to understand, in the second case, the x plus 1 on the top, it's a factor of 3, but then it's being added to 2. So it's not okay to cancel this x plus 1 with this x plus 1. That is not okay to do. And the reason it's not okay is because of that addition there at the end. So what we say is this: you should never, never, never cancel terms, whereas you can only cancel factors. And it's important to know the difference. Terms are separated by addition and subtraction. Separated by addition or subtraction. But factors are being multiplied. They're actually terms that are being multiplied. So if they're being multiplied, it's okay to cancel. But if they're separated by addition and subtraction, it's not okay to cancel. So when you look at example 1, this is not new. We did this last semester. These are all factors because they're all being multiplied. There's no addition and subtraction. And so what we learned last semester was, first of all, let's start with the 3 and the 12. I can simplify that to be 1/4. And if I simplify x squared over x, you can think of it as subtracting exponents if you want. That's going to leave me with an x on top. And if I simplify the y over y squared, again, you can think of it as subtracting exponents if you want. That's going to leave me with a y on the bottom. And probably on this one, you would say, hey, I don't really need that 1, right? Because 1 times x is just x, and so you don't have to write that 1. And this is what we would have done last semester. Okay, well, notice how number 2 is different because they're not all being multiplied, right? You have addition and subtraction. And so the way we're going to do this today, if you have addition and subtraction, you have to start by factoring, because we want it in factored form because that's when we can cancel. So on the top, I'm going to take out a common factor of 3. It's going to leave me with 2 minus k. And on the bottom, That's a difference of squares, so I can factor that to be k plus 2 and k minus 2. Okay, so now that I have it in factored form, I can look and see if I have anything that's the same, so I can cancel. What you notice, and here's kind of a little side note, what you may notice is, do you see on top I have a 2 minus k, but on bottom I have a k minus 2. Well, it might be hard to tell, but those are actually the same number. They represent the same number, except one's positive and one's negative. Take, for example, what if I let k equal 2? Then I would have 2 minus, actually I don't want 2. How about I let k equal 4? Sorry about that. If I let k equal 4, I'm going to have 2 minus 4 compared to 4 minus 2. Well, if you do the subtraction, one of them equals negative 2, one of them equals positive 2. The idea is they equal the same number, one's positive, one's negative, and that'll work no matter what I choose for k, just to kind of drive it home. Suppose I pick 10. If k is 10, I have 2 minus 10, or 10 minus 2. Well, one of them equals negative 8, the other one equals positive 8. Again, they represent the same value, it's just one's positive and one's negative. So with that in mind, anytime you see a 2 minus k or a k minus 2, you see a subtraction problem in parentheses, and they're the exact same variable, exact same numbers, right? Both are subtraction, but they're just in the opposite order. It's okay to cancel, but it'll leave a negative 1. And it doesn't matter if you put the negative 1 on top or on bottom, it just leaves a negative 1. I always put it on top just to, I don't know, do it the same way every time. And so what I end up with here for my answer, on top I have 3 times negative 1, that's negative 3. And on the bottom all I have is k plus 2. So this is the simplified version of the original. Okay, so look at number 3. Again, remember we said you have to factor. For example, I can't just go in there and cross out those p squareds. Why? Because they're both a part of addition. So before I can do any canceling, I need this to be in factored form. So on the top, I'm going to do trial and error, 2p. As you can imagine, you really need to have good factoring skills in order to be good at this section. I know I need different signs. Multiply to be 4. Notice I can't use 2 and 2 because of that first parenthesis. Remember we said you can't have a common factor in the same parenthesis. So I'm going to use 4 and 1. I'm going to put the 4 over here and the 1 here, but I still have to check it. Remember, in order to check, you look at outer and inner. So the outer is negative 8. The inner is positive p, and that's going to give me negative 7. But notice we don't want negative 7, we want positive 7. So what we learned back in our factoring days is that's an easy fix. If you have the right number for inside there, but just the wrong sign, an easy way to fix that is just to change the signs. So I'll swap the plus and minus, and now you can check it again, but you don't have to. You can check it again. It's going to give me a positive 7. Okay, so I went a little bit slower on that factoring, but we did a lot of factoring last semester. I expect you guys to be masters of factoring, so we're going to pick up the pace on the factoring part. On the bottom, there's only 2 terms, so it's not trial and error. So I try and take out a common factor. I'll take out a 5p. That's going to leave me with p plus 4. And so hopefully now you notice this p plus 4 cancels with this p plus 4. I cancel the entire thing. Why? Because it's a factor. Notice those 2 parentheses are being multiplied. Down here, there's an implied multiplication. So it's a factor. It's okay to cancel. But that's all I can cancel. I cannot cancel the p. I'm going to do this in pink. I cannot cancel that p and that p. Why? Because they are a part of an subtraction or multiplication. In other words, I can cancel an entire parenthesis that has addition in it if that parenthesis is a factor. But I can't cancel individual terms in the addition or subtraction. So I'm left with my final answer of 2p minus 1 all over 5p. Okay? And by the way, the best way to kind of get this all straight is just to do lots of examples. When you're doing the homework, you'll find that you have lots of questions. Make sure you ask, and you definitely check your work. Whenever we compare answers, you definitely need to check yours with mine, because otherwise you're going to be assuming something that's true that's just not. So make sure you're really conscientious about checking your work on these. Okay. Number 4, again, this is one like we've done in the, well, I guess it's kind of like what we've done in the past because it's just multiplication. There's no addition and subtraction. So you may remember when you first learned to multiply fractions back in, I don't know, third or fourth grade. I don't know when you first learned. Like if you have 2 over 3 times, I'll just say 1 over 5, right? We learned that for multiplication, you just multiply straight across. 2 times 1 is 2. 3 times 5 is 15, right? Multiplication, you just go straight across. Well, the same thing is true with rational expressions. Just because there's variables doesn't change those rules. So if I'm going to multiply straight across, I can just think of this as just one big giant fraction, right? So now, if I want to cancel, I can say, well, 7 goes into 14 2 times. I can say 5 goes into 15 3 times. Even though that 5 is being multiplied by a because it's a factor, it's okay to cancel the 5 and the 15. And then a squared over a, I mean, you can think of it as subtracting exponents if you want, but you could just picture, hey, this is like having a times a on the top and just a single a on the bottom. So won't that a cancel with the a squared and leave a single a? So my final answer, on the top, all I have left is 3a, and on the bottom, all I have left is 2. Okay? Again, look at number 5. Just because it's multiplication, I'm going to think of this as one big giant fraction. However, because of all the addition and subtraction, I need to factor each individual piece. So I'm going to start by factoring the top, this 5x minus 15. So I'll take out a 5 as a common factor, x minus 3. And because it's multiplication, I'll just go ahead and do the top and keep it all in one big fraction. So the 4x plus 12, I can take out a 4. It's going to leave me with an x plus 3. On the bottom, for the 3x plus 9, I'll take out a 3. Leaves me with x plus 3. And then for the 6x minus 18, I'll take out a 6. Leaves me with x minus 3. Okay, now that I've got it all completely factored, I can start canceling factors. Notice I forgot a parenthesis. I can start canceling factors. So this x minus 3 cancels with this x minus 3. Notice the x minus 3, even though the inside is subtraction, the parenthesis is the factor. So it's okay to cancel the entire parenthesis. I can cancel the x plus 3's. And now, where a lot of people would say, oh, 5 times 4 is 20 over 3 times 6, that's okay, but you're not done. So keep canceling. Like we could say, hey, the 4 and the 6, wouldn't that reduce to be 2 over 3? So now what I have left on top, 5 times 2 is 10, and on the bottom, 3 times 3 is 9. So this is completely factored. Okay, look at number 6. Multiplication, so I'm going to keep top on top, bottom on bottom, but still I'm going to factor. So on the top, x squared minus 25, it's a difference of squares. So x plus 5 and x minus 5. Okay. The top, I have a 10. Since it's being multiplied, it's okay to just put it up there on the top. On the bottom, for the 2x plus 10, I'm going to factor out a 2. So that's going to leave me with an x plus 5. And that's being multiplied by 5 minus x. So when I bring it over, I'm going to bring it in one big parenthesis, because that 5 minus x, this entire thing, is being multiplied by this entire thing. And so now I look to cancel the x plus 5's. Remember that little trick we talked about? Because this is an x minus 5 and this is a 5 minus x, those actually represent the same number, but they're negative of each other. So I just leave a -1 in place of one of them. But I can keep going. Doesn't 2 go into 10 5 times? So in this case, on the top, I have -5. And whenever everything cancels out, you have a 1 there. It's not a 0. You have a 1. But remember, we've said, you know, having a 1 on the bottom, you don't really need it. So I would just write my answer as -5. Okay, so how is division different? Well, remember in the old days when you learned to divide, you may remember a phrase that you learned: keep, change, flip. So you have to do all of those. Keep, change, flip. In other words, you keep the first fractions. I'll keep the 2 minus t keep the 2 minus t. So that's my keep. And then I change the division to multiplication. And then I flip the second fraction. So I'm going to think of this as 6 over t minus 2. Okay? And because it's multiplication, yes, I can think of it as all one big fraction. But remember, this is being multiplied by 6. And then the 8 is being multiplied by t minus 2. So it's probably best to think of those as being in parentheses. And so now I can cancel the t minus 2, 2 minus t, leave a negative 1, right? 6 over 8, doesn't 2 go into both of those? So 2 into 6, and then 2 into 8. And so what I have left on top is negative 3, and what I have left on bottom is 4. Okay, so keep, change, flip. So when we simplify this, I'm going to keep the first fraction. Now, when I bring it down, I'm going to go ahead and factor. So when I factor the numerator, using trial and error, right, because there's 3 terms, need a plus and a minus, 1 and 1, and I think I want to have the plus be with the 2x plus 1, because if you check your outer and inner, that'll give you the negative in the middle. I'll go ahead and factor the denominator. Again, it's trial and error. 2x and x, it's going to be all plus 3 and 1. I think I want the 3 and the 1. I'm just placing it so that I can make sure I get the 5 in the middle. So I am checking it. I'm leaving it on you to check your factoring. You can't just assume you have it right. So know that I'm checking it in my head. And then I change it to multiplication, and I flip them over. So that means this one is going to go on the top. So how about when I put it on the top, I go ahead and factor. So 2x and x. I need 3 and 1. And I need a plus and a minus. Check it. I think that'll give me the positive 1x in the middle. And so that means this is going to come to the bottom, and that's a difference of squares. So 2x plus 1, 2x minus 1. And like I said, because it's multiplication, I can think of this as just one big giant fraction. Pardon my terrible handwriting. I had to switch to a different pen. The other one stopped working. And so now I can cancel 2x plus 1 with 2x plus 1. It looks like 2x plus 3 with 2x plus 3. Now notice I can't cancel the x minus 1 and the x plus 1. Don't think that's the shortcut. Can't cancel a minus with a plus. So there's nothing left I can cancel. So on top, I actually have 2 of the x minus 1s. I could have written x minus 1 quantity squared if I wanted to. And on bottom, I have x plus 1 and 2x minus 1. And there's no need to multiply that out. We like factored form. In fact, when we get to the next chapter, we're going to talk about how we would graph that if it's in factored form. Okay, so let's try number 9. It would really be smart of you, if you're really working along like this would be a class scenario, if you paused the video, tried it yourself, and then came back and compared. So I'm just going to keep going. So I'll factor the numerator. I'm checking to make sure it gives me the 3 in the middle. Factor the denominator. Again, I'm checking to make sure it gives me the 5 in the middle. Change to multiplication. So flip over. So I'm going to factor, put this on the top. Checking to make sure when I plug in that it gives me the 10 in the middle. And then I'm going to factor. I think I need x plus 3 and x plus 2, right, in order to get the 5 in the middle. All right, now that it's factored, I can go in and start canceling. I've got x plus 2's to cancel, x plus 4's to cancel, x plus 1's to cancel, and it looks like the only thing I have left is x plus 6 on top and x plus 3 on the bottom. Okay? So it might be in class that that's all we do for the first day, and then the second day is when we might go on to this part, but I'm going to go ahead and put it in one video because it's not really that long of a video. So this is like a fraction over a fraction. Well, remember, in general, when you have a fraction, it means division. So one thing you could do is you could think of this as this being divided by this. And so if you have 10 over x minus 3 being divided by 2x minus 6, whoops, I don't know why I flipped it yet, divided by 5 over 2x minus 6, and then you could do like we did on the previous page and do the whole keep change flip. And that's fine, you know, exact same thing. Sometimes I will teach this method just to kind of save a step. When you do that, when you do your keep change flip, what actually happens is you end up with the outermost terms being multiplied. So you would end up with the 10 and the 2x minus 6 being multiplied. So 10 and 2x minus 6 over, and then you would end up with the innermost being multiplied. So the 5 times x minus 3. That's how it will end up if you do keep change flip. So let's do like what we would normally do, and let's factor. So on top, that 2x minus 6, I can take out a 2. So I already have a 10. And now I'm going to take out a 2, and that leaves me with x minus 3. And then on the bottom, I can't do anything. It's just 5 times x minus 3. And so now I can cancel, like we talked about, the x minus 3's. If I want, I could multiply 10 times 2 and get 20, and then cancel. But I could just cancel right now and say 5 goes into 10 2 times. And so all I have left on top, 2 times 2 is 4. On the bottom, if there's nothing there, it's like having a 1, and so my answer is just 4. Okay, so how about we do this? On this one, yeah, we have the idea of outer over inner. That's how you'll hear me say it. But instead of just writing them down like that, how about I write them down in factored form? So on the outer, the x squared minus 100, I'm going to do difference of squares, right? X plus 10, x minus 10. And since I know this is going to be multiplied by, remember, outer, by the x squared plus 7x minus 21, how about I go ahead and put that in factored form? Trial and error. Let's see, to get 21, I could do 7 times 3. That's not going to give me 7 in the middle. 21... No, I mean, I could try several things, but it's not going to work. Do you see that if I put in like a 7 and a 3, when I check it, I'm going to have 4x in the middle and not 7x. Well, what that tells me is it doesn't factor. Okay, so I'll just leave it alone. I'll just leave it as x squared plus 7x minus 21. We're not used to that because we're used to them always working out, but they don't have to. Okay, on the bottom, I have the inner. And notice on this one, there's nothing to factor, so I'm just going to have the x minus 3 being multiplied by the 10 minus x. And so I look and see if anything's going to cancel. It looks like 10 minus x and x minus 10, but that leaves negative 1. And nothing else is going to cancel. So on top, I'm going to put the negative 1 out in front. I have negative. I have x plus 10. And I have the x squared plus 7x minus 21. So there wasn't very much that canceled here. All over x minus 3. And that's it. Okay, I mean, if not much cancels, then not much cancels. And that's all we have left. Okay, so that is section 5.5.